Is that the one? Yeah. Okay, so actually I was just trying different moves, and it took me like 10 or 20 trials to beat him, but it was just by one, and pretty much the setup was, I mean, it was just vertical lines for two columns. Did he move?
It's annoying.
Yeah. And here, actually, what I did, if I proceeded with the vertical columns, I would lose because he sets up that way that there's no way I can win. There's going to be like, I don't know, 7-2 or something, 8-1. So I put one horizontal here, and I guess it. Oh, he doesn't move that way. All right, let's try again. Okay, but it works on my computer. I don't know why it doesn't work here. It's dots and boxes. All right. Let me see. No, he doesn't want to do that anymore, but he does it on my computer.
What do you do?
Well, when I put that here, he usually puts it up here, right? And from here, I can proceed and win by one because I can trick him in, like, he wants me to be greedy and take like let's say 3 boxes, but I take only one, and I let him take two, and that way I win by 5-4 eventually. But I don't know if I cannot connect my computer, but I can show it there and just in front of the class.
Okay, so it's doing something different. Do you
So
want to
now-
try doing the reverse symmetry on my computer, just like, you know, instead of having the red down below?
No, he always well, yeah, we can try, but
Let's see if he does it, if you put the one higher, you know, symmetrical.
you mean right? Okay, here you mean, right?
Right.
It's embarrassing. Actually,
But you said something that was really interesting. So.
right. Let me see. Maybe I'm. Yeah, you see. Let me try something. Oh yeah, I think no. He's doing something wrong, something different. I thought that, you know, because I played it so many times and I showed Johnny and I showed you last time, right? That
It might be also that they're
Maybe-
collecting data.
maybe,
winning and
yeah.
readjusting.
Because it was weird that it wasn't learning from me. It was just playing the same moves all the time, and I was able to win one by one box. But I can try on my computer and see if it works and see.
It's fine, but you're not supposed to win because you're first
Right.
player. Second player will win the optimal strategy.
Uh,
So I'm going to show you. You actually said something really important. You don't want to be greedy and grab the first box you see. And a nice illustration of this is in your book.
yeah, it works on my laptop.
Interesting.
Maybe you were just playing too much.
Okay. So they have a picture like this in your book where there's a bunch of horizontal lines, kind of the start that Andre had started where he was making vertical lines, so it's a symmetrical set, and it's kind of a boring looking thing. But what they wanted to show you from here is being greedy is not always the best strategy. And that's the trick of this. Sometimes you're going to have to sacrifice a box. So after I show you this, I want you to go back and play dots and boxes again, allowing the first time you see a box that can be filled, don't go fill in the box for yourself. See what you can do to block that person from the other person from filling in more boxes and let them have that one. So see what happens if you use that strategy instead. But here's what happens if we have this already set up, all the horizontals are set up, and if you allow the computer to do its play, it will try to do this vertically. When the next player goes, we're going to call the next player Alice, then there's no choice. You have to put a vertical bar somewhere. because all the horizontals are taken. And once she puts that vertical down, well, the next person's going to do what? Right? They're just going to go down the row and take everything they can, right? Because if you look now, the obvious thing to do is to grab all the boxes in that first row. And then you have to place the next line down after completing each box. So they say, oh, you're permitted an extra turn, but really the extra turn is what screws you up. The extra turn forces you to put down this one right here. And then she's going to go and complete all the boxes, right? And then she's forced to put the next one down in the front. Then he's going to do the same thing and then forced to put the next one down. And what happens is that Alice ends up winning because Bob was greedy. So greedy play didn't work here. So just taking every open box that you can and filling it in didn't work. So the strategy is not to be greedy. So if Bob was going and Alice had to put down her 1, which is the red, and Bob goes next, the idea is not to fill up and take and grab every box that you can, but to leave everything complete except 2 of these boxes here. You, of course, you just filled in this box, so you have to place another vertical line, so place the vertical line at the end. Well, Alice is going to capture those 2 boxes. Let's assume that Alice is going to play greedy, but Bob is not. And Bob keeps doing the same thing. And you end up with a filled-in box that looks like this, with Bob having more of the boxes than Alice, and therefore Bob wins. So I'm going to give you kind of a strategy, or the beginnings of it, but I'm going to put some more math machinery behind it. Some of what we're doing, what's interesting to me about game theorists or people that work in combinatorial games, it's kind of this, you play a game, you get interested in it, and then you have to develop the mathematical machinery and the language that goes around it. And it makes it very different than other areas of math. We talked about differential equations a little bit as a joke, but differential equations is a really old area developed by Euler and Newton. It's been going on. I mean, I taught a PDE course at the graduate level, and we actually had at the beginning of every lecture a history, because each one of the equations had a long history behind it. This type of stuff is not like that. So if you have a game that you're playing and developing it, you have to come up with the mathematics or how to pose it mathematically yourself. So what I was trying to tell you, Andre, is that you actually are thinking that way. How do you get that put down in formulas and things that you can move around with your math mind to come back and develop the optimal strategy and then beat Dr. Krupa when she comes in here as a visitor. So that, right? So this is what you want to do. You want to use your mathematical skills, your mathematical toolbox to build that machinery. So that's nice in some cases, because you don't have to sit there and read a ton of literature first to get started on a problem, which is one of the reasons I loved working with game theory and students, because a student can come to me and say, I want to do research. Say, okay, here's a game. Step 1, start playing it. And then we start building the machinery together. So at no point did I say, you have to have Calc 2, you have to have differential equations, and by the way, start reading this PDE book too on top of it. They could just start exploring. So that was what's beautiful about it. So what I'd like you to do now is to try this non-greedy strategy and see if you can get ahead a little bit better. You might get like 3 or 4 boxes. You might not win because the computer has an optimal algorithm set up in it. Do you have other explorers on there other than Safari?
No.
I wonder if it's because you have a Mac. I'm going to give you my computer and see if you can figure out how to beat that method.
Okay.
All right?